Okay. So your assessment on Tuesday, you need to get there pretty quickly. I'm in the process of cutting the thing down to 55 minutes, but we will not give you extra time. Okay, so you need to get there quickly, you need to start, you need to do it, and it will require you to work pretty quickly. Okay, so it's obviously not impossible, or else I wouldn't have set it like that, but it does require you to know your work well and to not fart around with it. Okay, you must work quickly through the test to be able to finish it. The 2 extra timey kids in this class will need to make a plan to be here through the break. Okay, to work through the break. All right, so you will be given the test, you will be given paper to write on. If you can bring a stapler to staple your test and the paper together, so be it. If you can't, I will staple the things for you afterwards. Okay, right. Did you have any problems with this section on population? Okay, you can't all mumble into masks, you nanas. Thanks, Tabsy. Any real problems with population? No. No, you're all okay. Okay, any problems? I'm a bit loath to ask this one. Any problems with human reproduction?
There's no practical.
Because it just becomes a bigger issue.
There's no practical.
There's no practical.
Yeah.
That's your problem. In this time of social distancing, I'm afraid you're going to have to tie a knot in it or do something until we go back. Go back to level. But how are you going to do it 2 meters distant?
We'll make a plan.
Okay. All right. Other than the fact that there's no practical, everybody okay with all the aspects of human reproduction? So I think really that the only problems that there are with human reproduction in terms of learning it or understanding it, for me the main thing is the ovarian and menstrual cycle and the hormonal control. That's the thing that I think you might glitch on the most. Okay, so make sure that you go back and understand that particular section. Okay. Is everybody up to date on the work?
Yes, sir.
Tino's not here, so.
Oh, right. He was the 9 people behind thing. Okay. All right, guys. So, going back to genetics.
Sorry, ma'am, before you do that, I just wanted to ask for the test relative to human reproduction and ecology. There's a few PowerPoints on human reproduction. Is it just the main one we need to study?
No. It's all of them. So, no. So, okay, right. Let's talk about this. So, it's all the ones that are under that heading, human reproduction. Oh, okay, let's do this. Let's make this clear. Under that heading, human reproduction,
Right.
there's the PowerPoints with voiceover, human reproduction, and that's the really long one.
Yeah.
Then there's contraception, STIs, and fetal alcohol syndrome, and amniocentesis and chorionic villus sampling.
There's a life cycle and extra loads.
Okay, right. So those ones,
And the womb.
those 5, I think I've just counted 5,
Yeah, it was fine.
but you know me. Okay, so those 5, human reproduction, that really long one, that was most of the lessons, that's the content you've definitely got to know. You also have to know, because it's in AIM 1 column in the SAGs, contraception. Yes. STIs, chorionic villus sampling, and FASD are in AIM 3. So it is recommended that you have an understanding of those concepts. And don't keep putting it off. Don't keep going, I don't have to learn it. I don't have to learn it. And then you get to matric exams and you discover that you do need to go through it. And then you completely run out of time. Because that's not going to help you in the least. Okay? Jade, what's the problem?
I'm just stressing out because it's a lot to do.
But Poppet, have I not been saying since like March,
No, I
learn this work every day?
Yes, no, definitely. I'm just really stressed.
Don't.
Don't stress.
Yeah, life's too short to stress.
So just like clarify for Tuesday, it's human reproduction and contraception.
No. Tuesday's population studies
Yes.
and all the human reproduction stuff,
So no contraception.
which includes contraceptives. Guys, okay, I'm going to say this again because it seems that it's not clear to you. Under that heading reproduction, everything that is under that heading is reproduction. There are 5 videos made of PowerPoints under that section. The biggest one is the one that's entitled Human Reproduction, but there's subsections of it that are separate videos.
And the STI class? Yes, yes.
AIM 3.
Because that's on Tuesday.
It's your choice whether you want to learn it for Tuesday. But it's also your choice whether you want to learn anything else.
So now really it's everything that we've done since lockdown started.
Yes.
All in an hour takes.
Yes.
Matt, can I just ask, so
Okay. Shh. Guys, please listen, otherwise I'm going to have 20 questions on the same topic again afterwards.
So it's a lot of work to learn for one test now. So, because obviously you got that one PowerPoint, that's like 200 slides alone. And then you got the other ones. And I know you did say to us a long time ago that you should know this. But even if you told us a long time ago we should know it, we haven't been studying all that work every day. So, man, what I'm trying to say is that it's only an hour exam. But
Exam.
I mean, yeah, it is. It's only an hour test, right? But we're being asked both sections, which means both sections can't be asked as in depth to prepare us for finals.
So don't you want to make it one section?
That's what I'm saying.
Okay, guys, it's been said.
Okay.
Don't worry about it. I know what I'm doing. You need to trust me on this. Just do it. Yes.
We have reading time per class.
No. It's a class test. How am I going to fit in reading time in a 60-minute test?
Then it's only 15 minutes.
Only if it's a cycle test.
This is longer than this.
Okay, guys, I'm struggling to hear. A masks, B
Is it like 50-50 between population and reproduction?
almost.
So which one's more?
I can't remember. No, I can't remember. I said it about 6 weeks ago.
Didn't you say it 6 weeks ago?
Yeah, I'm a hard worker. Okay, moving on. I'm now going to start teaching genetics, so don't get sad when the genetics test comes along and say you were busy talking while I was teaching genetics. Okay. All right, so terminology. Okay. Oh, that's not going to work, is it? Can you see that?
No, no.
Okay.
She asked us if you want
Okay, guys, it's really not going to do it for me if you're going to talk every 2 seconds every time I stop and close my mouth. Okay, diploid. That's the best I can do. Okay, diploid. Come, quickly. You can't sit and write everything down that I say. No, Life's too short.
Now, will this video be going on to the classroom?
Yes.
Ma'am, did you hit record?
Pardon?
Did you hit record? Because I just saw Matt open the thing.
I think I've pressed record. I was told to press the red thing and I've pressed the red thing.
Is it recording?
Yes, it says record. Okay, I'm going to start throwing you out. You talk, you go. All right. So, diploid. Quickly, definition. Going. And we're starting with Tubbsy. Go.
Oh,
I know, I might die of old age waiting here.
it's a haploid with two of them.
No. Okay, Amu, go.
I can't take questions right now. I don't know much. I'm not.
You can't take questions.
I'm on education. I'm right.
Okay, all right. Jade, out.
Me?
Yes, you were talking.
Oh, sorry. What, are you asking me any question? What
No, I'm throwing you out.
Oh, please.
Guys?
My future depends on
Well, it's not going well at the moment, so maybe give up. Okay. All right. Now, I have to say the following. If Matthew Fuller is putting his hand up, you know you need to worry. Go.
Okay, I'm taking a guess, ma'am. But like, it's
Oh, God.
it's a Sol 223.
How long did it take for me to not be happy to be back at school?
Today.
No, not even that.
2 minutes.
Yeah, about 15 minutes. Okay, right, go.
The word like this. It's like it's a soul that's got the, I lost my terminology, but it's got the genetic, it's got 46.
Only if it's a human
Oh yeah.
would it have 46. Josh.
It refers to a cell that has a full set of genetic data.
Sounds correct.
Only because it came from Josh. All right. The issue is die.
Yes.
Okay, so possessing two sets of chromosomes. One maternally derived and one paternally derived. In other words, for every homologue, there's another homologous chromosome with it. Helen, do you want to move? Okay. All right. So, in an organism where a somatic cell has 8 chromosomes, what is the haploid number?
4.
See?
Is it 4?
Yes.
Oh, no.
But Tabsy, you know why.
Yeah.
Yeah. You haven't done a good guess here.
Yeah, I do know.
Okay, right. Everybody happy with that? So, in a human, if a somatic cell has 46 chromosomes, what is the chromosome number of a sperm cell?
23.
Carrie,
Oh, sorry.
23. You happy with that? So, there would be in a haploid cell of a human. No, let's do a haploid cell of this one. 1 of chromosome 1, 1 of chromosome 2, 1 of chromosome 3, 1 of chromosome 4. Right? You happy with that? In that organism, in a haploid cell. If you're looking at a diploid cell of this organism, there will be 2 of chromosome 1, 2 of 2, 2 of 3, 2 of 4. Okay? Tell me the defining features which determine why these 2 are said to be homologous to each other. Vonda.
Same thing.
Same length. You need to say 5 things. But I'm happy if you say 2. I'm happy if you even say 1. Yes.
Is it the centrosome or the centromere?
centromere is in the same place on both of them. So the centromere is at the same position on both of them. So we've got same length, centromere is at the same position. Right, go.
Viva,
Mm.
sorry.
Julia.
They have genes for the same characteristics at the same place.
Absolutely. So this one, the third gene from this end, is a gene for skin color. Like this is a chameleon with green skin. Then this one, the third gene up from the bottom, would be a gene for the same characteristic. Remember that those two genes may be the same as each other. So they are for the same characteristic, but they may say the same thing. Then this organism is said to be homozygous for that characteristic. Okay? If those two genes for that characteristic in one organism are not the same, then that organism is said to be heterozygous for that characteristic. You okay with that? So if you, for example, hold up your thumbs, turn them this way. Okay, so Matt Fuller is, his characteristic for thumb shape is that he shows hitchhiker's thumb. Because if you look at his thumbs, come, hold them up, show the, very hitchhiker's thumb. Okay,
Why is it called
okay, right, so he's got hitchhiker's thumb, just like some of you have got brown eyes, some of you have got blue eyes, he's got hitchhiker's thumb. Okay, if, and I, off the top of my head, can't remember whether it's dominant or recessive. Do you remember from last term? I can't remember. Anyway, let's say that the gene for hitchhiker's thumb is dominant. What we don't know is if Matt is homozygous hitchhiker's thumb, because he does show the dominant characteristic, or whether he is heterozygous hitchhiker's thumb. However, and I'm not saying that hitchhiker's thumb gene is dominant. I'm saying if it is. And who was, Carmen, was it you who said you can't do that?
Yeah, my thoughts.
Okay, so her thumb is straight, and what we do know is that that would be her genotype. Because if the gene for hitchhiker's thumb is dominant and she can't bend her thumb, then that's her genotype. She's homozygous, straight thumbed. Now it's exactly the same with eye color. If you consider all the versions of the gene for eye color, and here I'm going to talk about eye color very simplistically. It's far more complicated than this, but let's just pretend that it's nice and simple like this. So there is a gene for brown eyes, and that gene is dominant. Okay, that allele is dominant. There is an allele for green eyes, and that is recessive to that one. Oh, I shouldn't have used this example. And then there is an allele for blue eyes. And the allele for blue eyes is recessive to green, but also recessive to brown. So it's recessive to green and it's recessive to brown. And therefore, if I look at somebody and I see that they've got blue eyes, Shanice, have you got blue? Then I know for a fact that her genotype is homozygous recessive. If I look at any one of you that's got brown eyes, I don't know whether Matt Fuller's genotype is like that or like that. I just know that he's got brown eyes. And because it's a dominant colour, I can't tell by looking at him whether he is homozygous brown-eyed or heterozygous brown-eyed. But I can tell from Charlize, because she's got blue eyes, that she's little b, little b. There's no other option. If there was something else in there, she wouldn't be blue-eyed. Do you understand that, guys? I've got 1 nod, 3 nods.
I'm confused.
Okay, how far back did you get confused?
Not that far. It's because I saw my notes from last term that I'm trying to still look at and understand and write new notes. I don't understand with the blue eyes, that's lowercase b, and then
Okay.
brown eyes higher.
So remember we last term spoke about choosing symbols.
Yeah.
Okay. And I said to you, I'll get back to you now, Poppet. I said to you that the way conventionally that the symbols are chosen, let's go back to this one because this one's the easiest one, is that you look at the gene that is dominant, the allele that is dominant, and that one always has the capital letter. So if the gene for hitchhiker's thumb is dominant, then the symbol that you're going to give it is capital H.
Double H.
No, capital H is the symbol for the allele.
Okay.
Okay, so capital H represents the allele for hitchhiker's thumb.
Okay, the animal.
Hitchhiker's, I don't know how you spell that, thumb. And straight thumbs is represented by lowercase h. Okay? Because it's relative to that one. So that is the allele for straight thumbs. Okay? Then I said to you that every organism in a diploid cell has 2 chromosomes which have genes for the same characteristic. So at that position there is a gene for thumb shape, and at that position there is a gene for thumb shape. They can be the same, in which case that individual is capital H, or little h, little h.
So what does the little h, why is it little h and not big H? What's the double H, like the higher case, the lower case? What's the difference?
I've just told you that.
Oh, okay, there you go. But then what happens if it's H, higher case, and then lower case? What does that mean?
Because that is dominant to that one, that individual still got hitchhiker's thumb.
But they still have the gene of straight thumb, but the one that's more dominant is the one with the...
That is shown.
So the one that's first is the one that's more dominant.
You always write the dominant one first, but it's not. It's the one that's capital letters that's dominant. And that's why I gave you the letters up there. Always give the letters at the beginning of the problem. So if the allele for brown eyes is dominant over the allele for blue eyes, then the symbols you're going to use are capital B represents brown eyes, and lowercase b represents the allele for blue eyes.
What happens if blue eyes is more dominant? Will it be lowercase b, big case b? Because so you're saying that the hitchhiker's thumb is the most dominant one, and that's why it's the...
Okay, there's no such thing as most dominant. It's dominant or it's recessive.
What happens if straight thumb is dominant? Would the lowercase h come first?
No. Then you would use different symbols.
Okay.
If straight thumbs were dominant, then the symbols that you would use is capital S represents the allele for straight thumbs, and lowercase s represents the allele for hitchhiker's thumbs. You would use different symbols.
Okay.
You look which one is dominant, and you choose the dominant one, and you give the uppercase letter of the dominant one is how you choose your symbols. So if the allele for tasting bitterness. Hey, yo! If the allele for tasting bitterness in Brussels sprouts is dominant, then the symbols that you're going to use is capital T is a taster, and lowercase t is an individual who doesn't taste that particular chemical, PTC. Okay. You sure, Sharp? Go home and learn it. Yes, Jack.
So we were speaking about in order for chromosomes to be
Yes.
homologs, they have to have the same length,
Okay.
essentially in the same position, and it was alleles in the same position. But what's the other two?
Alleles for the same characteristic in the same position. Okay. Or genes for the same characteristic in the same position. They have to have the same, if they are stained for banding, they would have the same banding pattern. But remember that they're not always stained for banding.
Right.
Okay, is that 4?
Yes.
Then there aren't 5.
Only 4.
I'm sure there's a 5th one. Can't think of it off the top of my head. Okay, right.
Is the thickness not one of them?
No.
Okay.
No, because they're all one molecule of DNA wound around histone proteins. They're not going to be thicker than the other. Okay, I'm listening.
So then just to get homozygous, the characteristics are either both dominant or both recessive. And then heterozygous means that the characteristics are different.
Okay, just be careful how you're expressing it.
Yeah.
So you've got the correct concept, but you're not saying it correctly. So if an organism is homozygous, the 2 alleles for that characteristic, or the 2 genes for that characteristic, are the same. And those were the 2 options. If the organism is heterozygous for a characteristic, then the 2 genes that that organism has for that characteristic are different. They're not the same. Yes, my angel, and I was meant to go back to you a while ago.
With the blue eyes one, is it only like if it's ABCD, does that mean that both parents need to have blue eyes?
No. Both parents could have been heterozygous for brown eyes. Big B, big B, big B, little b, big B, little b, and this little b and that little b fused child with blue eyes. In theory, what you cannot get, and this is why eye color is a little bit more complicated, you should not have 2 blue-eyed people having a brown-eyed child. Because that'll be big, a little b, and this will be little b, little b. Where are you going to get a big B in that combination? In theory, it shouldn't happen. However, I'm never saying that again in a class again, because I've had it before. And what am I to say? So it's complicated. No, it's hectic. First time it happened to me, I'm going, no. Okay, yes.
So I just think I figured it out. So if it's double little b, that means the blue eyes dominance. So let's say
No. Blue eyes is always recessive. But if there isn't a dominant gene there, little b, there's no big B to override it. It can only be little b.
Oh, and Daddy's got brown eyes, and he's got brown eyes. No, but wait, look. So the hitchhiker's thumb. So if like the dominant gene is straight thumbs, will it be double little h?
No, if the dominant gene is straight thumbs, then you're not using the symbols H, you're using the symbols S. Okay, go home, think about it. Okay, right, we all happy, we going? Okay, yes, love?
What happens if someone has
Oh, that's a mutation. So as they're developed along the way, at some stage a mutation happens. And the cells that develop into that eye mutate into green. 2 eyes within 1 eye. Sorry, 2 colors within 1 No, that's way, that's a
So is that a specific? When you roll your tongue.
I'm colours all over the context, not just colour, not just That's skin colour. Okay, all right. Okay, let's have a look at the notes and see. Okay, so we, okay, I'm on page 2, not on the notes, the worksheet.
What notes are those?
This worksheet of problems, this one, it looks like this at the front.
Oh, I have it. This one.
Yes. Okay, right, going.
Good.
Okay,
Oh, yes, it's my fault.
has it got a table? Yes. Okay. Right, so I need you by tomorrow to have made sure. Okay. So on page 1, and you should have done this last term already. No one? Okay.
I was actually.
Yeah, sorry, no, I'm not criticizing.
Oh.
Sorry.
I
Okay.
was meant to catch him up, but never got to.
Okay. Right. On the first page, under terminology, you can do 1, 2, 3, 4,
Thank you.
5. You have no idea. This thing is not. So it's not.
Are you serious?
I promise you, it's no wonder I've got a headache. A, it's tight around here, and B, it's. Okay. All right. Okay, you can do 5. We need to go back to 6 again. Anyway, go ahead. Under the differentiation between terms, you can do 1, you can do 3, you can do 4, 5, and 6. Okay. All right.
What's up?
Carmen, this is yours.
What?
This is yours
The short questions.
of the short questions on page 2.
I swear this was for homework last time.
It
Yeah,
was.
I did it. We did it last time.
Okay, right. No, but we're going. Because I'm going through it again, because otherwise you won't remember. Okay. If the gene for long wings is dominant over the allele for short wings in Drosophila, which are a kind of fruit fly, what symbols would you use to represent long wings, and what symbols would you use to represent short wings? And stop cheating by looking at what you wrote last term.
No, I'm not. No.
Go. Long wings.
What? I'm confused. I thought you were explaining the word.
No, now we're going on to problems, love.
Yeah, but what about them?
You've got to answer the first one on page 2, Puppet.
Number 1, C1. C1.
Okay.
Okay. I don't know. I don't think she I didn't do number 1, but I did the rest. But I understood it last term, so I got all of them right. So I don't understand what's going on now.
Okay, William, go.
No, ma'am. Can I go get my file?
No,
I bought the wrong one.
I've given you like 50 messages. I spend my life sending you guys messages. Bring your file, bring your this.
Oh, I just forgot
I'm
to
over
put
it.
it in that one.
No,
Okay.
I'm over it. Okay, right, Trish, go.
That's C1.
Please, please.
Capital L.
Are we listening?
Yes. Capital L, small l.
Which one is capital L and which one is small l? You have to say which one is which.
Long L is the capital.
Long wings.
Long wing.
Okay.
Sorry.
All right.
Long wing is
So capital L represents long wings, lowercase l represents short wings.
I'm not saying that she's wrong, but wouldn't it be more correct if it's bigger case W and smaller case W?
No, that wing means wings and no wings.
Crazy.
Okay. Bonga? Okay, look at me. I can roll my tongue. Okay? It's a dominant allele.
Oh.
Are you going to use for your symbols capital R for ability to roll tongue,
Oh, no, no, no.
lowercase r,
Oh,
or
no.
you can use big T, little t? Big T, little t means no tongue or tongue. Okay.
Okay.
Okay, so it's the characteristics that you're looking at. Alright, everybody happy?
No, what do we use?
So here, okay, so Trish said big L represents long wings because long wings is dominant. Little L represents short wings and fruit flies because short wings is recessive to long wings. Bonga's question was, why are we not using big W, little w? And big W, little w would represent having wings and not having wings. The issue is not whether this organism has wings or not. It's whether or not the wings are long or whether they're short. And so that's the thing that you're looking at. And so you've got to use big L for long wings, little L for short wings. Which one's dominant, Carmen?
The big owl.
Okay, long wings. Okay. From the list alongside, pick out all of the organisms that are homozygous for a characteristic. Okay, write them down there if you didn't write them last term. In fact, cover your answers. Let's go. Okay, Matthew V, go. All the organisms that are homozygous. Now listen carefully before we start how you're going to say this, because I just know what you're going to do. You're going to go GG. And I have no idea whether you mean capital G, lowercase g, whatever. So the way you're going to say this is like this. Big G, big G. Little g, little g. Little t, big W, little w, little w. Thank you, Mrs. Page, for answering my question for me. Okay, so those are all the organisms that are homozygous for a characteristic. I'm not enjoying this. Please make it go away.
That's illegal.
Ma'am, even like a mask like this on the stage.
No, I know, but then you're not going to be able to hear me.
No, we will.
But no, it's nothing to do with that. It's all to do with you being a bunch of pups. No. No.
Ma'am, I think it's just when lockdown started, we started with the population thing, and then went on to human reproduction. So genetics is now like under the rug and on top of the rug.
I know, but love, I've started it again. Okay. All right. So all of the organisms that are heterozygous for a characteristic. And Kwezi, go.
Big Z, small z, big T, small t, big W, small w, big G, small g.
Good. Did you look at your answers? No, you've covered them. I love you. Okay. All of the organisms that are pure breeding. Now listen carefully to me. The term pure breeding is the same as the term homozygous. It means exactly the same thing. If an organism is homozygous, it's also pure breeding. Okay. So all of the organisms that are homozygous, Matthew V, are pure breeding. Go.
Man, funny story.
Oh, God. Big G, little g, big T, little t, big W, little w. It's exactly the same as the organisms that are homozygous. You get that? Okay. All of the organisms that are hybrid. Now listen carefully. The term hybrid is exactly the same as the term heterozygous. It means exactly the same thing. So on this board, this organism is hybrid. Okay. Are the bells going?
No.
So somebody intelligent, okay,
Yeah.
that means you.
We have 8 minutes.
Okay. All right. Hey, stop arguing. This organism is also heterozygous or hybrid. Homozygous. Okay. Or pure breeding. You could have used the same term for them. Okay. Now, new thing. So let's have a look. Remember that when a cell divides by meiosis to form gametes, the chromosome number is halved. And one of each homologous pair will go to different gametes. That means that a gamete will only have one chromosome of a homologous pair. Okay, so if an organism is heterozygous for a characteristic, half of the gametes are going to have, and by scientific convention you always circle gametes. Half of the gametes are going to be like this, and half of the gametes are going to be like that. Which means that if one is looking at a male, and that male produces 1 million sperm in a day, 500,000. 500,000 are going to have that, and 500,000 are going to have that. Statistically, a female would 1 month, in theory, have this, and the next month that. In reality, it doesn't quite happen like that, but statistically it should. Okay. Right, you happy? So, if we're looking at problem 2, and I say to you, here is an individual that is homozygous, big A, big A. List all the possible gametes that can be produced by that organism. Doesn't matter how many gametes that organism produces, they're all going to have big A. Right. Big Z, little z. Half of the gametes are going to be big Z. Half of the gametes are going to be little z. Don't make the gamete smaller. It's not the gamete that's smaller, it's the letter that's smaller. Be very careful with certain letters. There are certain letters where it's really difficult to tell the difference between an uppercase letter and a lowercase letter. You must make it very clear. S's, M's, N's, W's. You must make it very clear the difference between your upper and your lowercase. Little b, doesn't matter how many gametes that organism produces. All little b. Okay. Big B, little b, I've already done for you. Half of them are going to be big B, half of them are going to be little b. Charlize.
So with regards to pure breeding, if, I don't know why, but is true breeding the same as pure breeding?
There are 3 words that mean the same there. Homozygous, pure breeding, true breeding. All mean the same thing. Okay, right. Everybody happy? Okay. Please make sure that you read through your textbook page 101 to 105. Okay. All right, for tomorrow. Okay.
Wait, I want to say 100 to 105.
101 to 105.
Thank you, ma'am.
Right, and please make sure that you learn this work for tomorrow, because tomorrow, full steam ahead, doing genetics problems. Best you understand this work.
Thanks, ma'am.
And you're learning for your test. Oh.